so it's a Fermi integral, Fermi-Dirac integral, order 1/2. Since it cannot be solved, we have to numerically solve it. So if you're solving semiconductor problems exactly, use a computer to solve this. If you're doing a hand calculation, we're like, oh man, now what am I going to do, right? And then you come up with an approximation. So if you take ECE 542, which I teach a lot, okay, we run into something that looks like this, and I'm like, we can't handle this, here's an approximation, and we move on, right? You take something more advanced, we revisit this, okay? But because this course is about numerically solving things, it's perfect for solving this integral. And I'll show you how MATLAB makes this super easy, right? So you don't have to know why we use this equation, right? We just need to learn how to solve it. So me, the professor, said, hey, there's this fun integral, why don't we solve it? And you, the student, says, oh man, I gotta solve it, right? Okay, so what we have is this integral with a bunch of stuff in it. It has both x and t, but it's a definite integral, so the t disappears, right? We do the integration, we take the limits, right? The lower bound, the upper bound, we solve it, and we get an answer. So it is a function of t, but only inside here, right? The dt, the t disappears after the substitution. So only this function here, f 1/2 is Fermi-Dirac integral of order 1/2 is a function of x. The t disappears. Okay, so to do the homework, what we have to do is, hopefully you've been working on this homework due today, and plus, there was a lecture a week ago. Okay, so we have an integral command, and you give it a function to solve. And the function to be solved is everything inside the integral. Well, that depends upon x and t. So you have to create a function to implement that integrand, right, as a function of x and t. So two inputs. Then, as a warm-up, number 2 here says evaluate it at x equal to 0. Right, so you can just type integral, all this stuff, and you put 0 in for x. See what number you get. Okay. Third thing, I want you to plot this for a range of values of x from -1 to 1. But for each point here, we have to solve the integral. So I'll go through and explain how we do that today, right? And how we can go through step by step and evaluate the integral and get all our values of y on the y-axis for values of that, right? As a function of x. And so you make a plot. So what do you submit? The same things as always, right? Your script file, a published PDF file, and if you created any .m functions, include those, right? There are 3 ways of making functions. If you do it with the .m file, you have to include it. If you do it either the other 2 methods, you don't have another .m file, right? So I leave that up to you, right? Yes?
For homework 1, for homework 4,
yeah.
Number 1, we're supposed to create
Having trouble hearing you. That's
for the last homework.
Yeah.
For number 1, we were actually supposed to create a separate .m file. Right?
Yes. You have to create a separate .m file, right? I'm forcing you to do it all 3 ways on the homework due today, right? So you have to do it with the .m for the homework due today. For the one due next week, you got 3 methods of making a function. Choose whichever one you like. If you like it in a separate file, do that. If you like it in a script file, do that. If you like what's called an anonymous function in the middle of things, do that, right? Yeah, so I'm assuming homework 4, you learned how to do it a variety of ways. Homework 5, we can just do things how you want. Okay, and then to help you a little bit, right? here's the answer at x equals to -1 and x equals 1. So if you get those values, you're like, yay, right? And you can feel good and be confident that you got the correct plot. If you don't get these numbers, you're like, uh-oh, there's a mistake. And then try to fix it, right? And so if you can get these numbers here, right, and be confident, right, you can get 100%, and that's perfect, right? I love giving 100%. It means you learned something. It means all is good, right? And I think you like to give that 100% as well. So, so I'm just putting that there because it's easy to make a mistake somewhere, and having some idea of what the answer should be is helpful, right? Because in the real world, you got a function. Usually you're checking things somewhere, right? Some sanity check to make sure that your code is correct. So let's look at how we go about this, right? So last class, we looked at how to do a function, and so I put some functions at the very end. I got function y is equal to f of x, so f is now a function, right? And it's at the end of my script file because all functions that are defined this way have to be at the end of the script file. They cannot be in the middle. Why? I have no idea. You'd think that MATLAB would make this possible to put it at different places in the file because it actually reads that file to get to the end, you know? But I don't know. Okay, so we got y is equal to f of x, and last class I did an example where we took sine x times cosine x. So let's do that as a quick review. If I execute this code right here, it finds sine of x times cosine x, sine of at x equal to 0, sine of 0 is 0, cosine of 0 is 1, 0 times 1 is 0, and I get an answer of 0. Woohoo! Right? Very nice. And if we want to plot things, right, what I have here, it'll go from 0 to 2 pi so that we can get a plot. Again, same example as last time. Y is equal to f of x to get a bunch of values, right? We feed in a vector or an array for x, and it computes it on every value of x and gives us an array back for y. And then we can plot x comma y. And we can find an integral from 0 to 2 pi. So if we run this, here's our plot from 0 to 2 pi, right? It's sort of looks like a sine wave, right? But it's not, right? It's a sine times a cosine. Goes up and down and up and down. Does not reach plus and minus 1, okay? Because it's sine times cosine. But it's periodic, okay? And so if I integrate from 0 to 2 pi, just looking at things, 0 is in the middle there. I expect it to be 0. It should be 0. MATLAB says, no, it's actually 4.3368 times 10 to the minus 17. Okay, so MATLAB's not perfect, right? This is what happens when you numerically compute things, and that's why you took a calculus class and learned how to solve things, you know, the exact way. Computers are great, but not perfect. Okay. So that's what we did last class. So now let's do a more interesting problem, right? Now I want to do, let's plot an exponential decay, exponent of minus t, right? That's a function of time that shows up all the time if I have a capacitor. Charge up the capacitor, I'm like, yay, I have a charged capacitor connected to a load. The voltage decays exponentially with time. Okay, so in this case, it'd be a time constant of 1, right? Because it should be minus t over tau. Let's start by plotting this. So I'll plot from 0 to 5. I created a function f decay of t, and we'll plot it. But what's that function? Sitting here, y is equal to exponent minus t, right? Pretty simple. So if I run it, I get this nice exponential decay. That's what happens in a capacitor, right? I could run it past 5, but if you look real close, 5 time constants. That blue line is almost at the x-axis, but not exactly at the x-axis. Don't we learn in the circuits course that takes about 5 time constants, or like 99.something% of your voltage is dropped, but not 100% up. Okay, so we can see that. I don't know, if you're in the back of the room, maybe you can't. I'm up close, I can see it. Right? There's this small difference. And now, I want to find the integral under the area of this curve, from 0 to infinity. Ooh, numerically up to infinity. Right? Do I have to keep calculating things for an infinite amount of time? Answer is no, I can get MATLAB to do this. So if I put this function right here, I say, let's run it, I get the answer 1. So what happened? Here's my function, f dk. My lower limit is 0. My upper limit is I in f for infinity. If you remember your homework that I'm giving you, there's a lower limit of 0 and an upper limit of infinity. So guess what? You have to put this in here for one of your bounds. So there we go. There's half of the difficulty of your homework problem, right? That's how we handle it. Pretty nice that MATLAB does that. The other way MATLAB couldn't handle it is we would have wrote a big number in, right? Such that it converges on that number. And I'll bet internally that's what MATLAB does, right? But we don't have to figure it out. Now let's complicate things a little bit more, right? So I have this capacitor, I charge up its voltage, and I put a resistor on it. But how fast does it decay in voltage? It has a time constant. Tau is equal to resistance times capacitance. RC time constant. Well, then it decays not as negative t, it decays as negative t over tau. And that's the equation for the decay. So let's set up another function that looks like this. So I'll call this f decay 2, right? So that we have another function. And it takes 2 inputs. One is t, the time. The other is our time constant. Okay? So now I have 2 inputs to this function, 1 output. That kind of looks like on your homework when you got it integrated with both x and t. Okay? You set up a function with both of them. Okay. We're up here. So let's do 2 plots. One with a time constant of 1, and the other plot with a time constant of 2. I've superimposed them, right? So I figure to plot one of them, plot the other one, make sure I do a hold on instead it's held on, and I don't erase it when I do the second plot. I run this, and we get this wonderful plot. Make it bigger so that you have a better chance of seeing things, right? At time equal to 1. One of the plots is, it's about 0.35, but I'm not perfect yet. 1, right? It's at 1.05, right? So about, right, for an exponential decay after 1 time constant, they're about like 36% at the initial value. But the other one had a time constant of 2. So we're about the same point. But it took 2 seconds before you got to that point. So this blue curve is for a time constant of 1. This red curve is for a time constant of 2. It takes longer for the voltage to decay. Now, how do I integrate things? Ooh, this is the tricky part. So let's just do 2 of them real quick, right? So I'm going to integrate with a time constant of 1, and a time constant of 2. So I'm going to do 2 integrals. the limits go from 0 to infinity. I got an integral statement, but I had two inputs to my function, f(dk2). So now this is the tricky part, right? I have to let MATLAB know how to integrate this, right? Because I'm only integrating with respect to one variable. So let's integrate with respect to t. That's what I did 5 minutes ago, right? From 0 to infinity. How does MATLAB know which of the two inputs is being used? Because as far as MATLAB is concerned, I can use the variable x, I can use the variable y, t, right? I can use someone's name, right? I can use anything for these variable names. It doesn't know what's what, it doesn't know what's going on. So here's what I do. I put this at sign at t. Now it says, oh, when I see t, I know that I'm doing a function with respect to t. And this works for more than one variable as well. I could do at x comma y or something, okay? But we don't need to do that today. So I do at t, and then it says I'm going to have a function with respect to t. Now it sees f(dk), which takes two variables. One of the variables will be t. There we go. So now MATLAB says, oh, that's what I'm integrating with respect to t. I'll plug it in here. It knows how to handle it now. But the other input, it's like, what do I do? And so what do you do with the other one? Give it a value. So now the first line here is the integral of dk2 of our exponential minus t over tau, with tau equal to 1, because that was our second input on the function. The other one will be the integral t from 0 to infinity with tau equal to 2, because that's what we defined, right? So this is the tricky part, right? And I'll put this up onto Blackboard so that you have this in text, okay? But this is the tricky part, and now we can integrate something, only one variable constant, and integrate over another variable. In this case, integrate from 0 to infinity. If I run the section, I get answers 1 and 2. What does that say? Integrate, right? Before I had 1, right? So I still got 1, right? For a tau of 1. Same answer. But when I had tau of 2, now look under the curve, it turned out to have that area 2. Right? So that's the red curve. And you can see there's more area under the red curve than under the blue curve. I could not have told you that's exactly twice as much. Okay? I mean, if I did the math, yeah, I could work this out. But looking at the two graphs, I couldn't do that. Okay? Turns out to be exactly twice the area under the curve. Well, let's take this one step further. I can get the value for tau is 1. I can get the value for tau is 2. What's the value for tau is 3? What's the value for tau is 7? Why not make a plot of this integral versus tau? Okay. Now, I'm going to tell you this is somewhat of a trivial answer because guess what? I put tau equal to 3, I'm going to get 3. So if I make a plot where my integral turns out to be equal to tau, okay, it's going to be straight line. But let's watch that. Let's see how we would do it in MATLAB, right? So we know we'll get a straight line. That's like, okay, right? I like to try to do things that aren't so hard for learning it, and then I make you do something a little bit harder on them, right? Something a little bit more interesting on them. Okay, so we have that one. What I want to do now is set up tau as an array because that's going to be my x-axis. And let's go from 0 to 10. Okay? Now, I'll put this word try here, and you can look at my notes ahead. It says, this failed. Okay, so my first try was to just put tau in right here. And this is going to fail miserably. Let's watch it fail. Yeah. I tried, and I get an error message, right? And it's like, okay, so that this line 89, that's right here, error in integral, error in integral calc, and if I keep going up, be adapt, I mean, it's 10. But finally, I find this message, matrix dimensions must agree. So what failed on us, right? Okay, so what failed is, here's my function. I'm taking an exponent, it'll do it on the matrix, no problem. But I got negative t over tau. I just plugged it. It's an array, but array is a one-dimensional matrix, right? Into tau. It had how many elements? 1,001 elements in it. But I can see that in the upper right. Right, because I went from 0 to 10 with a step of 0.01, so including the 0, right, I get 1,001 points. So now t needs to be 1,001 points if I'm going to do a dot divide. But how big is the matrix for t? That's what I'm integrating over, and I have no idea. It's as big as MATLAB wants to use. There might be one number, there might be 10 numbers, there might be 100 numbers, right? And since MATLAB iterates a few times, it probably throws a couple of numbers of arrays of different sizes at this function and says, do this. That was nice. I'm doing it again. That was nice. Try these numbers, right? And just until it's happy, right? And performs the integration. So I don't know how big t will be. I cannot tell how big t is going to be. And when it does the integration, I should be getting one number back. But I don't want to create this x-ray of tau and get one number back. I want a bunch of numbers, right? For every tau, I need a value of y. So this doesn't work, right? So the matrix dimensions don't agree because you cannot send a matrix in where it needs a constant. Okay, tau has to be a constant. So here's what I'm going to do. And so okay, it fails. What do we do, right? And that's a bunch of questions. Good news is I know what to do. So we set up tau again, right? Same thing. This time, I'm going to set up a for loop, and for every value of tau, I'm going to compute the integral. Right? So I got a for loop, and I'll loop through it. Every value of tau, I evaluate the integral. But I have to be careful here. I cannot say tau, I cannot say for tau or whatever, right? I don't want the values of tau. I need to index through tau. Okay? And so it's a little bit of a pain, but it'll work. So if I go through for A, and A is going to be an index, right? I got an array with 1,001 things in it, and I'm going to find the first thing in tau, which would be 0, the second thing in tau, which would be 0.01, the third thing in tau, which is 0.02, the fourth thing in tau, which is 0.03, right? And on and on and on, and the 1,000th thing in tau, which would be 9.99, and the 1,001th element in tau, which would be 10. 1,001 times I'll go through this work, right? And A will be 1, 2, 3, 4, 5, up until 1,001, so that I can step through tau. So it's called an index, or step through it. How many points? Well, I'm going to use this function called length. could have put 1001 in here, and it would work perfectly fine. But if I say from one corner the length of tau, then I can come up here and change things. I don't have to change the number here, right? Because the length function will figure out what the new length is, and always use the correct number. So I like that. It's more robust. It means that it makes it easier for me to change things, right? So I like this format, right? So A is an index, that's step 2. Now I need Y, and I need 1001 things out of Y, because first I need to compute it for the first thing in tau, which was 0. I find the integral for tau is 0, negative Y, put it into an array at location number 1. Not tau 0, right? At location number 1. If I try to just use tau in here, right? For the first thing in tau, I'd be in trouble because it has to go in location number 1. It's an integer. But tau goes 0, 0.01, 0.02, so I can't use tau. I need an index. So this is the key here, right? So Y, parentheses A, first time round, A is 1. We put it into first thing in Y. Second time round, A is 2, put it into second thing in Y. For all 1001 things, and we have our integral at t, because we're integrating over t, f of dk, 2. First input is t, second one is tau, but which tau? I index it with an A. Right? Tau parenthesis A in parentheses. And then I get it. And so this time it'll work, right? So let's run it, no errors, and I get this wonderful straight line, right? Could have just written y is equal to x, but you know, did it the hard way. Because the hard way allowed me to show you all these fun commands. All right, so yeah, I think that's how we would do things, and so that's how you do the homework, right? You are going to create a function, right? Let's go find out. Step 1, create a function to implement the integrand. It has 2 inputs to it. Step 2, as a warm-up, let's do just one point. Make sure it works, right? Yes?
Would the length function
Yes.
give the number of rows and columns, or would it just give like the number of columns?
Yeah, length only works for one-dimensional thing, okay? If you need the number of rows and columns, use size, S-I-Z-E. That'll get you both of them, and yeah, great question. Let me show you real quick what you need to do, because it returns 2 things, so you have to be careful with that, right? What I would do here is size of size of tau. Give me 1 and 1001, right? But if I want them both in variables, right, I could do a. I think add that like this. So see, this is the funny thing. If you return more than one variable, you have to put it into a matrix and put your 2 variables here, so that it puts the first thing it returns into the first part of the matrix, and the second thing it returns into the second part of the matrix. Because MATLAB thinks everything is a matrix, right? And so it says, oh, how to return more than one thing? Put it into a matrix. Yeah, right? Matrix laboratory, MATLAB, yeah, everything's a matrix. And so then I can get these 2 numbers separated, and then I can do my loop or whatever I need to know about it. Yeah. So length is great for 1D, sizes we have more than one dimension. Okay, so first we create the function number 2, a warm-up, just to evaluate at x equal to 0, because then the hard part is x becomes your x-axis, right? And then you have to set up a for loop, right? And I'm reminding you that set up a for loop, evaluate the integral for each thing, and then make your plot. You get this wonderful plot. It is not a straight line, right? And here are 2 points on it, so you see those. And if I execute it without showing you the code, because I can't make things too easy, right? But this is your plot. It looks something like this. It doesn't look something like this. It looks identical to this, right? You get this plot, I'd say, hooray, and I give you 100%. Okay? Okay, so that's all I want to do with the lecture at this point. I'd like to help you, but if you have questions about anything, homework due today, next homework, anything. I'm guessing homework due today is high on your interest list. I think you have a question. Okay.
It was really not working very well for me when I was using lid space for X and Y, and like trying to do a mesh grid with having that different space, but when I switched over to like just a regular array, it started to look better. Like it's actually graphing now. So is there like some kind of not understanding of lid space?
Yeah, I don't know. Lens space, okay, so the question is using lens space, right? Lens space should be in first, a start, an end, and then number of points. Right? Should have worked. I think it should have worked. Okay. I can play around with it, but you know, you're saying something of like, it should have worked. So maybe there's some nuance here that I'm not aware of, but I really think it should have worked. Because it's starting them out with evenly spaced just the same way. I think it should have worked. You're giving it more than 1 point, right? If you don't give it more than 1 point, I think it'd be a problem, right? But yeah, I've used lid space a million times, right? And I just put 1,000 in, right? That way, instead of getting, I can't see now, but instead of 1,001 points, I get 1,000 points. Rounds that number out. Any other questions? Tell me what, maybe you're done, right? You can head on home or your next class or whatever, right? If you're not done and you're stuck and want to ask me one-on-one, we can do that. Okay? So, no more lecture, free to go.